As you begin working on the surface area and volume unit in 8th grade math, we want to look at the TEKs and some of the resources that are available to you, as well as looking at some of the nuances of the TEK as you prepare for assessments, both summative and formative. If you will access the secondary math arc via the icon on your computer and select the 8th grade math section, the volume and surface area is the second unit listed in the second 6 weeks. Your at a glance gives you a big picture of what the year looks like ahead. Clicking on that, you go to your timeline, let you know that you have 13 instructional days in which to teach and assess this material. The line across the box across the middle of the screen right here lets you know that as well as looking at the teach, you can check on some assessment resources, tell past writing prompts. There's vocabulary, words with pictures, and ways for students to remember keywords. Instructional resources are listed there. A lot of the textbook as well as some of the other resources available to you are listed. Let's look at the TEKs. For this unit, there are four TEKs listed. Two of them are readiness standards noted by the green R. The other two are supporting standards. We'll look at the readiness TEKs and also identify how the supporting standards can be used in teaching those in conjunction with one another. 8.7a, click on that. When you click on that, you'll go to a page that will show you the core components for the TEK, as well as the vertical alignment. And almost all of the ones I've looked at, there is a looking back alignment to show you how this concept has been developed over the last at least 3 years. And in many of them, there is a looking ahead just to show you what the information you are teaching ties into. Let's first look at the TEK itself and some nuances about how it's phrased. Look at the core components, and we'll kind of give you a big picture of how they've gotten to this point. 8.7a says solve problems. So that's a pretty common verb there. You're going to find solutions to problems. But notice the problems are listed as involving the volume of cylinders, spheres, and cones. So be careful not to just make problems that calculate volume, but problems that involve the concept of volume. And I'll show you what I mean by that in just a second. The core components help us a lot. The specific solids have been provided. Notice there are no pyramids and there are no prisms where you'll have to find volume. Estimation is still included, as any work with pi will require an estimation of pi. Pi, as you know, is an irrational number. So whatever version, 3.14, 22 over 7, you're expected to be able to use both of those, as well as the pi button on the calculator. And again, any rounded version of the answer would be an estimation of pi. But what's not listed here and implied is that they'll also have to be able to answer in terms of pi, whereas you just leave pi alone and let it float through the problem. So your answer has some multiplier of pi. Now, if you look back at 5th grade, they dealt with perimeter and area as it related to volume. You see they're kind of building that concept of area of the base times the height. In 6th grade, there were more area TEKs, as well as, if you look at the last part of this, the volume of right rectangular prisms where the dimensions are positive rational numbers. And then last year, and again, these TEKs are being implemented, so you might see some gaps there. But in 7th grade, they're using models to approximate the formulas for the circumference and area of a circle and connect the models to the actual formula. So they're building in this understanding, looking at the model where the formula for things come from. And you will see that when we look at your surface area TEK. The phrase involving the volume, I wanted to just show you a couple of images here of cylinders, spheres, and cones. I know you know what they are, but when you look at a problem involving the volume may be given and the radius of the base might be given, and the student has to find the height. Or they have the height of the volume and they have to find the area of the base. There are a lot of different things that you could do with those problems involving the volume. So pay careful attention to all the dimensions that are used in the volume calculations. Consult your formula chart and make sure that they're solving for any and all of those unknowns. So going back to the vertical alignment, we're going to look at the second readiness teak. Again, we're going to click on that teak and access the core components as well as the vertical alignment. Now this teak has two main verbs, so we're going to make sure we look at both of those. The first one is to use, employ, use previous knowledge of surface area to make connections to the formulas for lateral and total surface area. That's the first part of that teak, and driven by that first phrase, use the previous knowledge. So in our core components, it helps us know where that previous knowledge comes from. Previous knowledge, as referenced, is determining surface area from nets. So if you look at the core component, or you look at the teak in 7th grade, they found that the lateral and total surface area by simply using the net and finding the area of each individual face on that shape. So what you've got to do now in 8th grade is play off of that connection. So it is not a net building teak anymore as much as it is a net referencing teak, or a net connecting teak to the algebraic representation, or in other words, the formula for total and lateral surface area. The second verb in there is to determine solutions. So again, we're not just connecting that teak, but we're going to use those formulas to find solutions. Now, again, we've got this phrase for problems involving. So just as we mentioned earlier, when we looked at the volume, we want to make sure we look at problems involving the surface area. So we've got prisms, rectangular and triangular, as well as cylinders that are mentioned in our teaks. Pay careful attention to all of the dimensions that are possible for a student to be able to solve for when you're looking at the idea of surface area. The great part about this teak, like the other one, is we have very specific shapes mentioned: rectangular prisms, triangular prisms, and cylinders. I want to point out that the background knowledge that from 7th grade included rectangular prisms and triangular prisms, but it did not include cylinders. So you'll want to make that connection. Also very interesting is that the cylinder is the only common shape of your two teaks in this, the two readiness teaks. So you are going to find the volume of a cylinder, and you are going to find the surface area and total surface area of the cylinder, and work with problems that do both. We've got specificity. Again, pyramids and cones are not included here. Pyramids and prisms were not included in the volume teaks. Let's go back and look at the supporting standards and see how those can be connected to the two readiness teaks. Describe the volume formula. Volume equals area of the base times height of a cylinder in terms of its base area and its height. So what you're looking at there is making sure that students can indeed articulate that the area or the volume of the cylinder is not just BH, but the pi r squared to find the area of the base times the height. The core component includes substitution of area formulas in place of capital B. A lot of kids come out of the lower grades just believing that volume is length times width times height. And so there's this progression throughout the 5th, 6th, and 7th to begin implementing that idea of the area of the base times the height. And when we go back and look at the other supporting standard, it is modeling the relationship between the volume of a cylinder and that of a cone. Now, I like this teak because you can have a lot of fun with it. If you look at the shapes again, you can actually take a cone of the same base area of a cylinder and the same height of a cylinder, fill this with water, and pour it into the cylinder, and you'd have to fill this 3 times to fill this one up. So students can connect the formula of this being 1/3 the area of the base times the height simply by that experience. They'll also want to make sure that they can articulate that a cone will be 1/3 of a cylinder that has the same base area and height, or a cylinder would be 3 times that. So they want to make that relationship and model that. So it's a fun opportunity in class to get their hands wet, possibly. There are also some videos online that you can Google that just show that very succinctly. Connect those relationships. So when you look at those teaks and think about the nuances of problems involving the volume and problems involving the lateral and total surface area, when you make sure you stay specific to the only shapes that are mentioned in the teak, that will help you define very clearly what type of assessment questions, both formative and summative, that you'll need to use in conjunction with teaching this unit on volume and surface area for those 13 days.